All right. If you have any questions, you can type in our chat box and then we can read it towards the end, or Tyler will answer like in the middle, I mean, during the presentations. So Tyler, welcome. Thank you very much for coming to our chapter for today. Talk about loss of productivity. I'll turn the stage over to you.
Perfect. Let me go ahead and share my screen and let's get started. All right. Are you able to see my screen?
Yes, yes.
Perfect. All right. Just a quick agenda here. I'll do a quick introduction. We'll talk about what is productivity, what isn't productivity, mind the grammar there, quantifying productivity losses, and then we'll do a wrap up and some Q&A. I've seen the sign up sheet. I know many of you and many of you know me. If you do not know me, my name is Tyler Conter. I work at Point Construction Advisory Group, where I am a claims consultant, which typically means that I get involved with projects after they are already completed and there was some type of issue on that project that is now being resolved through some legal channel. I have a Bachelor of Science in Civil Engineering from Florida State University. I am a licensed professional engineer in the civil discipline in Florida, Kentucky, and Tennessee. I am also a certified cost professional through AACE and a PSP, also through AACE. Most of my practice revolves around forensic schedule analysis, as well as loss of productivity claims, acceleration claims, dispute resolution, things like that. I would say probably 90% of what I do has to do, after a lawsuit is filed and it is understood that a claim is not going to be dealt with on the commercial level. It's going to go through a legal channel, as I described, but I do get involved proactively on some projects to help mitigate claims before they escalate beyond the project. I lecture at universities, including my alma mater of FSU, different events through AACE. I also teach various CLE courses for construction law firms across the country as well. Goals and rules for today. I want you to learn a couple things to take back to your projects. Some things you can probably go ahead and implement, or at least start tracking from day one. I have a plan. I have a presentation. I'm going to follow that presentation, but if you would like to interject and say something immediately, then go on right ahead. We have one recording for this, and that is the one being taken by the event organizer. Please don't snip anything off my screen or try and create your own recording. I do that because I don't want anything mischaracterized. There will be some chances for participation here. And if you have an immediate question, feel free to put it in the chat and we can deal with that. And as always, just be respectful of each other. So let's start and just talk about some impact types. And this is just general information. If you are not familiar with the different types of claims that we encounter on construction projects, we have delays. What this essentially boils down to is the project is taking longer than planned. And within a delay, we have delays that are critical, meaning that they are delaying the overall duration of a project, and we have delays that are non-critical. These are delaying a specific scope of work, but not necessarily the duration of the project overall. We have productivity losses that are going to be the focus of what we discussed today. What that boils down to at a very high level is additional hours are expended to accomplish a quantity of work. We had a plan, or we measured we were performing at a certain level of productivity, and that was impacted, and now we have a loss of productivity. We have acceleration compression claims, where work has to be accomplished faster than originally planned, and we also have claims sometimes for additional work. Typically issues with design where we have additional quantities, or changes in site conditions require us to take on more work. So before I discuss anything, let's just do a quick knowledge test on productivity and delay, and kind of understanding the differences between the two. So let's say AZ Contracting has 10 days to complete 1,000 lineal feet of underground conduit, and it planned to take 150 hours, we'll call them man hours, to complete this work. A to Z Contracting completed the work in 11 days, and it took 200 hours to complete the work. Was there a delay? Go ahead and put it in the chat, whatever you think. Anybody? Yes. See some yeses. The answer is yes. Was there a loss of productivity? See a couple yeses here. The answer to both of these questions is yes. We did have a delay of a day, and we did have a loss of productivity. We have taken more hours to install the same amount of widgets. In this case, our widgets are lineal feet of underground conduit. Let's go to another quick example here. Let's say A to Z Contracting had 10 days to complete 1,000 feet, once again, of underground conduit, and planned to take 150 hours. There was a change order, and we added 300 additional lineal feet of conduit, and we got a time extension of 3 days. A to Z Contracting completed the work in 12 days, and it took 275 hours to complete the work. So let me ask you the same questions here. Was there a delay? No, I see no's. We have a time extension that takes us out and gives us 13 days of contract time. We complete in 12, there is no delay. Was there a loss of productivity? There's no delay, but is there a loss of productivity? No, hide the chat window here, so if you're doing some math, you can figure that out. Come on, anybody with a loss of productivity? Did we experience a loss of productivity? Okay, I see one yes, I see two yeses. I see a percentage number that I'm not going to check here live. The answer is yes, we did experience a loss of productivity here. So no delay, but there was a loss of productivity. The lesson here is that a lot of people, and I see this a lot in my position, is they conflate the two, delay and productivity, as having to be simultaneous, or that if there is a delay, it can immediately be chalked up to productivity losses. These are different impacts and we measure them differently. You can have one without the other. And before we actually move into the meat of the presentation, I always like to stress the three facets of every claim. We have entitlement, impact, and cost. If you're familiar with my presentations, I always have this slide in here because it's very important to understand that all three of these things have to be part of any type of claim, be that a delay claim, a differing site condition claim, a productivity loss claim. Why in this order? Well, without entitlement, the other two don't matter. Without an impact, how are you going to have cost? Things like that. I'm working on something right now where we have an issue and the contract explicitly forbids productivity claims, says they can't claim productivity. And while I'm not a lawyer, and that lends itself to be more of a legal argument as to whether or not that's enforceable, it's definitely something that needs to be taken into account and discussed with legal as part of the first step in a loss of productivity claim. Once again, we have to cover all these facets to maximize recovery. So let's talk about what productivity is. People have been measuring productivity for thousands and thousands of years. Essentially what productivity boils down to is the ratio of your inputs to your outputs. When we think about this, we think about man hours per unit complete. This is really where you want to be when you are measuring productivity. We think about 1,000 man hours to install 5,000 lineal feet of pipe, something like that. If that information isn't available, you can kind of gauge down to lower tiers of measurement. The one I have directly below here is crew hours per physical percent complete. That's also a measurement that can be taken from a project, but it's less favorable than actually having hours in units. What it boils down to, though, and there's an untold amount of different combinations here. We have some measurable input divided by some measurable output. So what do you need to make a good productivity measurement? You need quantity information for the component that you're analyzing. Think lineal feet or inches or meters cubed if we're working with earthwork or something like that. And then we need the labor hours required to install those quantities. Those are two things. And although this may seem really easy, I can tell you in my experience of analyzing, I think I'm well up over a couple hundred projects now, retrospectively. It's a very rare occurrence that we have this information in enough granularity to be able to perform an adequate measurement of productivity. Either we can't match the hours to the quantities or vice versa, or some of the information is missing. And I will say many organizations have the systems in place to track these things over time and over their projects. It just seems like a lot of times either, we get started and we have a very good start tracking quantities and hours up front, and we tend to put those reports on the back burner as we get into the meat of the project, or they're just ignored altogether. Essentially what it boils down to is keeping good records in the most granular level of detail that you can get to on your projects. Best productivity information always comes from the project that you were analyzing. And we'll touch more on that later. Up till now, we did not discuss time. There's nothing to do with time right now. When we talk about productivity, we can be completely separate and in a bubble from time. This is where I typically make a good distinction here, because these are two other concepts that very often get conflated: productivity and production. Production here, I have the equation right in front of you, is going to be those outputs divided by time. You know, when we talk about production, we talk about lineal feet per day, or meters cubed per hour, or air handling units per week. I've seen it before. You have a project with dozens and dozens of AHUs to be installed over a large time frame. Loss of productivity does not automatically correlate to scheduled delay, as we've established earlier in the presentation, whereas a loss of production will result in delays, or will most likely result in delays. If you cannot keep your production up, that's when you're going to start incurring delays. Can you have a loss of productivity and no loss of production? We will discuss that. And then notice we're not talking anything about cost yet. We are talking solely about the distinction between productivity and production. So let's break this out into a scenario. Let's say we have a subcontractor that is doing excavation on a large industrial project and plans to move 1,000 cubic meters a day, utilizing 100 crew hours. What is the planned production? What is the planned productivity? Our planned production is in the problem statement, right? Our planned production is 1,000 cubic meters a day. Our planned productivity, if you do the math, is 0.1 crew hours for every one of those cubic meters that we move. Let's say our subcontractor mobilizes to the job, and then, you know, here in the first couple days, we realize that the site condition is different. Okay, this may sound familiar to some of you. This is a very common scenario. After a few days of excavation, the subcontractor measures its daily output and realizes it's only moving 500 cubes a day, or half of its planned production, using the same crew and hours. What should it do? What is its productivity? If anybody wants to go ahead and put that in the chat, let me know. Just ignore the bullet point below it. What should this subcontractor do? Yep, I see a comment here from Mr. Bolliard. Did I address your comment here about the differences between productivity and production? Excellent. So anyway, what is this contractor to do if they get into it now? We see we are only producing half of what we've done, or half of what we planned. Variations should be submitted. Correct. Add more laborers. Add a crew or a shift to regain. Sub needs to understand why production is less. Okay, all of those are really good points to take away here. First thing we need to do is notify somebody. Your typical construction contract has a 3-day notice period, or a 5-day notice period, or if it's really lenient, has a 14 working day notice period. You're going to need to submit a notice to your GC, and your GC is going to go ahead and pass through your notice to the owner, and you know, one of two things are going to happen. For this example, we are going to make the assumption that we get a change directive from the general contractor to maintain the schedule, meaning that we need to maintain production. So our last bullet point here, we are producing 500 cubes a day using our crew hours. Therefore, we are taking 0.2 crew hours per meter cubed. Notice it's taking us twice the amount of crew hours per cubic meter of soil. If the subcontractor does not increase its daily hours, it will incur production losses and will most likely incur scheduled delays. All right, so taking into account our assumptions that we have provided notice, we have received a change directive to maintain the schedule from the GC and to track costs associated with this. Subcontractor is going to mobilize an additional crew working the same number of hours of the original crew, and they're going to go ahead and track their cost to mobilize this crew and plan on filing a pass-through claim for a differing site condition as outlined in the contract. We're going to assume that we follow the correct channels in the contract, and we are now working 200 crew hours a day. So we take our original measured productivity of 0.2 crew hours for every cube of soil that we have to move, and we are multiplying it by our new input, 200 crew hours a day, and we are back to our original production. And let's go ahead and say, make the other assumption here that we have adequate space to mobilize these two crews and have them working on top of each other. And the first and second crews are able to achieve the same production that was measured in the previous slide. I'll go out and say here that there are times where that's not the case. You can mitigate productivity by mobilizing more labor, more crews up to a certain point. But it's a logarithmic function. At a certain point, you're doing more damage than you are good by continuing to throw bodies at something. Especially when you talk about something that's not excavation. When we talk about work in confined spaces, we see this a lot in vertical construction, where we'll have a mechanical contractor who is behind and may be impacted in some way and now has to make up a lot of time, or they're accelerated by an owner. A lot of times, the quick and easy solution of throwing more bodies at it is the least effective, and it requires more creative solution. So down here at the bottom, I just want to say that this comes at a cost. Not only do you have the cost of mobilizing another crew, think about all the things that happen when you mobilize your original crew. You probably have new safety orientation, you have new badging, you have equipment costs associated with it. There are a lot of costs that go with taking this approach to mitigating losses in production. So let's talk about what isn't productivity. Let's go ahead and reiterate that there is a major difference between productivity and production. Productivity losses do not always mean scheduled delays. There are mitigations that you can do to overcome productivity losses, like I discussed. We can have additional manpower. We can work overtime. We can work on the weekends. Sometimes the first two that you see there are the answer. Obviously, overtime comes with an additional cost per labor hour. Weekend work may also come with an additional cost per labor hour expended. But if you're in a situation where you have spatial constraints, that may be the best route to take. Scheduled delays can be a result of unmitigated productivity losses leading to a loss in production. I think everybody can tell by now, I'm trying to ensure that everybody understands that it's not necessarily the productivity loss that leads to scheduled delay, it's the loss of production. There are other reasons why scheduled delays occur. You can't chalk up scheduled delays to productivity losses without performing a measurement. I see this a lot with contractor claims, and I see this more often than not with subcontractors, especially smaller subcontractors that may not have the internal level of sophistication to adequately quantify their claim. What they end up doing is called a total cost claim, which we'll get back to later, and then saying it's all related to loss of productivity, even though we've never measured the productivity or performed any analysis, to prove that there is an actual loss of productivity on the job. And, to take a step further, the measurement is only half the story. A lot of times there is no causation analysis to accompany that total cost claim as well. So overcoming losses in productivity can be costly. Make sure that you track the cost. For all of our cost people on the call here, I would highly recommend segregating this cost, under a different cost code, or isolating it as a discrete impact item when you track it contemporaneously. So somebody like me doesn't have to go back and see a total amount of actual hours expended and try and decide which were input as as part of the original scope of work, and which were input as a result of trying to mitigate a loss of productivity caused by some other issue. So we've talked about productivity, we've talked about production, we've talked about delays, we've talked about how all those pieces interrelate to each other. Let's talk about measuring loss of productivity in different ways that we do that. Let's also talk about kind of the hierarchy of measuring productivity, and which pieces, which methods are more favorable and which ones are less favorable. Really, this is a curtailed list here. There are dozens of different ways to measure loss of productivity. I'm going to cover a few here and kind of their pros and cons. Something everybody on this call probably should have heard of at some point is the measured mile study. This is probably the most widely accepted method, of calculating loss of productivity. Essentially, it boils down to a comparison of impacted versus non-impacted work. There are a lot of different variants of this. Once again, with each of those variants having its own hierarchy of validity. Second method is comparison to a similar project. This has elements that are similar to a measured mile analysis, but the information is coming from a separate project altogether. Next one we have here is modified total cost. It's a cost-based approach. It's not necessarily a measure of productivity, right? The thing that differentiates this from a total cost is just a removal of certain aspects of total cost claim that are either a bid inaccuracy or some type of owned loss that the contractor, the subcontractor identifies. And then there is a whole slew of industry studies, MCAA, NECA, BLS, Leonard, Army Corps, ACO factors. I think they got rid of ACO factors in the 90s. There are countless studies of productivity. Most of them are very academic in nature, very theoretical, but they all kind of suffer from some of the same drawbacks and issues. Last thing is just total cost. This is probably the least favorable method of calculating loss of productivity. Once again, because it's not a measurement of productivity, it's a measurement of cost. And the situation I described earlier, where a subcontractor will suffer some type of loss on the project and chalk it all up to productivity by providing a total cost claim, is all too common. So let's talk about the measured mile. This is going to be AACE 25R03. It's a great publication. I would highly recommend reading it and garnering some insights, but I will summarize kind of the big points of it here. It's used for estimating lost labor productivity in construction claims. It's a comparison of work performance in an unimpacted period, and this should say, or least impacted period, to an impacted period. I make that distinction because there are many times where you may not have a completely unimpacted period. The impact just may be to a lesser degree than the remainder of the project. We need to compare similar work activities here. I'll get into that in a little more detail. Essentially, your lost productivity is going to be that productivity measurement that I started out the presentation with in our baseline versus the productivity actual. The measured mile, it's been given the moniker the gold standard in terms of reliability for quantifying inefficiencies. Yeah, I would say that's accurate. I would say this is probably the most reliable method for a myriad of reasons. First and foremost, the information that you're using comes directly from the project at hand, incorporates all those conditions. Where do you get your data for a measured mile? Daily reports, when you're garnering actual labor hours and actual quantities installed. Job cost reports will also have actual hours tracked. And like I've alluded to earlier, some organizations actually maintain a labor productivity report that essentially automates this process if maintained properly. Really, what this boils down to, the key to reconstructing productivity information is good record keeping. If you do this week in and week out and maintain it, this should be a breeze, and it should be a very strong analysis. It's where sometimes we have to question the validity of some things, or there's some issues. Rules of credit is something that comes up very often. That we start having to be more creative in how we select our periods and what hours to incorporate. I put together a little example here, the measured mile, and we're just going to call this plumbing. How realistic that is, maybe for a very small job, but there are all types of plumbing activities, right? One of the things you don't want to be doing is comparing the implementation of 12-inch pipe to 3-inch pipe, right? Those are not what I would describe as like scopes of work, especially if the information is available for you to get to a more granular understanding and representation. So first thing we do is select a non-impacted or least impacted measured mile period. Here's our quantity for that period. It's the 43,799 here. Then here are the actual hours used to install it. And we come up with a productivity of, a little over 0.1 hours per unit, per widget here in whatever unit we're doing. And we do the same thing for our impacted period. Let's say during this period, we have the HVAC contractor working on top of us, and we're submitting a claim for the general contractor to go back and back charge our HVAC contractor because they had to come back and rework on top of us for this period. That's another very common scenario. We go through the same math, and what we see here is that we get a little over 0.25 hours per unit here. In our impacted period, our unimpacted period, we do a comparison of those, and what we see here is it takes almost twice, or actually over twice as many man hours to install each widget. We go ahead and multiply that by the total period quantity from our impacted period, our 160,173. What we find out is that we have a little over 21,000 lost or otherwise unproductive hours. Any questions on this or this process here? Going once, going twice. Okay, we'll go ahead and move on. Simple enough, right? All of these things seem really simple until you realize that you don't have hours to match a specific quantity, or you don't have quantities that align with the hours. Can always become problematic, and that's, like I said, when you have to be a bit more creative in how you're defining your quantities and how you're defining your hours. So what makes for a good measured mile? It's going to be comparison of like scopes of work. And when I mean like scopes of work, I mean as like as you possibly can. You don't say I had, 100 cubes of concrete on floor 1 of the project, and I had 100 cubes of concrete on floor 10 of the project, and I'm going to compare them, and they're going to be similar. You know, something like my example here, concrete flat work and concrete walls are going to have inherently different productivities, just naturally. And that just has to do with the nature of the work. Your best measured mile is going to come from a comparison of, in this case, if we have hours of quantity information for a concrete wall in the same vicinity as another concrete wall, and we know one was impacted, that's really going to give you your best result. Selection of the impacted or unimpacted or least impacted method. This is something people get themselves into trouble with. A lot of times what I see when I'm rebutting claims, even from experts, is you see a lot of cherry picking in the unimpacted period. Either it's a 5-year project and we happen to pick the very best day, or the information has been skewed to some degree like that. You really need to pick an adequate sample size for the overall scope of work. And I'm not going to get into what adequate is, but my example there, if you have a 5-year scope of work and you have the work going on for the entirety of the 5 years, you don't pick your best day and that's your comparison. Once again, you need work that's similar to what's being compared in 2 periods, apples to apples. And you need accurate selection of the impact period that is in alignment with the impact. Let me stop here and point out a problem that I frequently see. Your bid productivity is not your unimpacted period. Let me repeat that. Your bid productivity is not the unimpacted period in the measured mile. And I will tell you why. Your bid productivity is a forecast. That's what you planned on doing. Nobody ever, if you're going to use that, you need to demonstrate that unimpacted, you actually performed at that bid productivity under the actual site conditions, and that you were able to perform at a specific productivity when unimpacted anyways. Typically what you see when somebody has used the bid productivity leads to a total cost situation, as we described. Essentially, you're saying that any hours above and beyond what you bid are the result of loss of productivity, and they're somebody else's fault. Let me ask you this: can you perform better than your bid? And don't rack your brain on this too much, but I want to see what everybody thinks. See a yes. See another yes. I see a bunch of yeses, so that's good. Yes, you can perform better than your bid. You absolutely can. Like I said, your bid is just a forecast. If you can demonstrate through and stay in alignment with some of the bullet points above, that you were able to perform better than your bid for an adequate sample size in your unimpacted or least impacted period, then absolutely, that should be your measurement. And what if the source of your bid productivity was from a similar project completed the year before? Well, the answer to that one is obviously yes as well. Shut down the chat here. All right, I think we've beaten the measured mile into the ground, and I think everybody should have a good understanding of that. Let's talk about the measured miles. I'll call it estranged cousin, the comparison to a similar project method. This typically falls just below the measured mile on the hierarchy of acceptable methods, and this is typically something used when in a couple different situations. Either on one project we have missing or incomplete information. One project we have adequate information to be able to perform a comparison, or we have a project long issue on one project and we can't establish an unimpacted or least impacted period. Now, I will say that we follow very similar steps in quantifying this as the measured mile, but you have to take some very special precautions when you do this, or it really does come under scrutiny. These projects need to be as similar as possible. A good case here, and this is something I worked on a few years ago, is a data center that's being constructed directly next to its sister project. Essentially, two identical buildings of the same size in the same region, being constructed by the same contractor, the same subcontractors, and the same crews. The only difference where the subsurface conditions of one were different than the others. And that tended to plague the project for its entirety, and we were unable to establish an unimpacted period on it, at least for the portion that we were analyzing. These projects are as similar as can be, and that's really the key takeaway here. If you're going to compare it to a similar project, is you don't take a hydroelectric dam in Newfoundland, Canada, and compare it to one in Argentina, being built by different contractors under different sets of conditions, different seasonal constraints, things like that. That's one way to get yourself in trouble forming this method. Once again, very similar to the measured mile. The measurement of productivity on the impacted project is compared to the unimpacted project, going through the same channels and the same math. Let's talk about factored analyses. Use of productivity factors there are so many studies out there, and different organizations put out different factors. These are some of probably the most common: the MCA factors, the NECA factors. BLS even at one point put out their own factors. Guys, essentially what these do is attempt to apply an outside measured loss of productivity to the measured productivity on a project. This information doesn't come from your project. This is some objective factor that has been around for a while. We're going to talk about where they come from. What problems do you guys see with this? What issues do you think could arise from taking a factor and from a publication and applying it to your project? Might not be applicable. We have another question I'll get back to. Might not be applicable to your project. Yeah, of course. using MCA for work that is not mechanical, or I should say NECA for work that's not electrical. Yeah, I've seen that as well. I've worked on a project where it was a large infrastructure project, but the bulk of the contract value here was excavation, and the contractor took a shot at quantifying their lost productivity using the MCA factors. I revised that analysis and actually ended up with a pretty good outcome there. Let me go back to David's question here. Would it be unreasonable to use the bid productivity as the unimpacted period if the bid productivity were based on historic similar scope, determining? Once again, anytime you're using your bid productivity, you're using a forecast. I would say if you're basing your bid productivity off a similar project, I would say just move to a comparison to that similar project's productivity. So if I'm not going to spend a lot of time picking on MCA, but I might. If you're familiar with these factors, it really looks something like this. We have, and there are a lot more than this. We have a bunch of different factors here. We have fatigue and logistics and site access, and we have a percent of loss per factor, and we gauge the impact based on our own subjective assessment of how bad the impact was. Guys, right off the bat, one of the things I see with this is if I'm preparing a claim and I have an issue with site access that I believe is the fault of an owner, I'm automatically going to jump to that 30% and say our site access is horrible. I mean, it's just a very subjective way about going about measuring. Essentially what these do is they are added, you can take 4 or 5 of these factors and stick them together and come up with a productivity claim. Here's an example here, just using the MCA factors. Let's say we had 2,000 actual earthwork hours, and we just want to discuss what our loss of productivity was on our contract hours. So we take out our change order hours and we get 1,500 hours. And through our own assessment, we say we have 10% due to dilution of supervision, and we'll call it 15% on errors and omissions. And we've come up with the 25% loss factor by adding those together. We're going to take our 1,500 hours that we spent, and we're going to take our loss factor and add 1 to it. And we're going to get the 25% loss there. And we're going to say that we have 300 lost or otherwise unproductive hours. And, with this 30-second spiel, we performed our productivity analysis. We're going to send this to the owner, and they're just going to cut us a check. That does not happen. I have never seen that approach successful. I think the MCA factors, and I think any factors, and I'll get to where they come from here in a minute, have their purpose. But I don't think it's in quantifying a productivity claim retrospectively. I think if you want to take these, because as I'm going to say, they're based off the experience of people who are spent a lot of time in the field or did spend a lot of time in the field, and use them to understand maybe a prospective impact or something you should anticipate. That may be a good use for them, but retrospectively quantifying a productivity claim, I would not recommend this. So let's talk about where they do come from. And let me represent to you that what I am showing you is a signed affidavit from the former president of MCAA in a case in, I believe, 2000 with the VA hospital, he was subpoenaed to provide information as to the origin and usage of MCAA factors. And I won't read this for you, but here's what he had to say about MCAA factor usage. See, somebody said, weren't these MCAA factors developed for forward pricing changes? I believe they were. Unfortunately, they have devolved into becoming some organizations' way of quantifying losses of productivity to submit claims. And here's what we say about the origin of the MCAA factors. And I'll take any questions you have in the comments here. And just to prove I'm not lying to you, here is the final sheet of the notarized affidavit talking about the origin and usage of these. And I was wrong. This is from 1999, not 2000. So just to sum it up, there are a lot of factors and different analyses out there. They all suffer from the same flaw. There are a nearly endless range of potential project conditions, and you can't sum it up by some objective factor that may or may not be applicable for your project and type of impact that you're having. As I've mentioned, these things are performed because they're quick and easy. And as always, the best analyses rely on actual project documentation for the project being constructed. I won't spend too much time on this because I want to leave some time for questions, but as I've described before, total cost and modified total cost. These are not measures of productivity. These are measures of cost. This is essentially saying, here's what our original direct labor cost was for this scope of work or this project, and here's how much we spent. Please cut me a check. Once again, it's typically an unsuccessful way of going about this. It's what I will categorize or characterize as one of the more unfavorable methods in relation to some of the other ones I've discussed, like the measured mile or comparison to a similar project. So let's go ahead and wrap this thing up. The preferred methods here, I've listed these in order. You're always going to want to perform some type of measured mile for the reasons I've described before. If you can't do that, or you have a lack of information or a major impact, we can go to comparison to a similar project. We have modified total cost here and up above industry studies, because sometimes a modified total cost will do a good job at taking actual project documentation and describing a discrete impact to cut out. And then here at the very bottom, we have total cost. So once again, tracking the data during the project has profound benefits. For the organization as a whole, for understanding, how you're performing over time, especially on many projects, many years and decades. It's not something you do just for claims and litigation. What questions can I answer for anybody? Go ahead and take some questions now. We can do them live, or we can put them in the chat. I'll do my best.
I guess I'll throw out a question. To your point there, I would just say it sounds like using the PERT method based on historical data, and over several projects, sounds like it would rank up there with comparison to similar projects as you had suggested, and maybe even in between the two as maybe a slightly preferred method is comparing it to a single historical project, as you'd be comparing it to multiple projects and deriving some, pessimistic, optimistic time from that.
I would be careful with that solely because, the idea that your PERT method has incorporated a multitude of projects that are, maybe different degrees of similarity to the project that you're analyzing may cause some issues.
Sure.
Anybody else? Perfect. Well, all right, everybody. If we don't have any more questions, I appreciate your time and I appreciate you tuning in. I hope you got something from this. And, if you have a question that comes to mind later, feel free to reach out on LinkedIn or something. Hope everybody enjoys the rest of their day. Thank you.